Hello and welcome to our new video. Today we discuss about the Fourier series. When we start the Fourier series, first we have to know about the periodic function. What is the meaning of the periodic function? Period. You already know the periodic. Periodic means any function which repeats from a certain time interval. So if I say that period is t, then value of fx plus t is equal to value of that given function. So for this t time period, this function will be repeats. So this is called periodic function. For example, it means for after every t, it will be repeats. So fx, value of fx is x plus t, x plus 2t, x plus 3t up to x plus nt. Similarly, in the negative side, if it is repeats in t time interval, then fx is equal to fx minus t, fx minus 2t, fx minus 3t and so on. So periodic function, it means it repeats after a particular time interval. So when we talk about the periodic function, very simple, our trigonometrical function, sine, cosine, tangent, all are the periodic function. Sine, cosine, sec, cosec, all are repeats after the t is equal to 2 pi. Time interval 2 pi, and tan and cot, tangent and cot repeats after pi interval. So its time period is pi. So when we know about the periodic function, then we go for the Fourier series. Fourier series is basically, what is this? Fourier series is very useful for any function given expand into a periodic function or expand into a sine and cosine series. So any function, with the help of this Fourier series, we can expand that function in sine and cosine series. Means we can convert that function into periodic function, and that is very useful in many places. Fourier series are using for conduction of heat, mechanical vibration, and in many telecommunication things you can use the Fourier series. So let us see what is the formula for Fourier series. So Fourier series is defined fx equal to a0 by 2 plus summation n going from 1 to infinity an cos nx plus bn sin nx. Means we can see this function we can expand in terms of sine and cosine series, where a0, an, bn all are the Fourier constant. All are called the Fourier constant, and we can calculate this constant with the help of Euler's formula. I can give you what are the Euler's formula, how we can derive this. So a0 is given by, if this Fourier series for particular interval from c to next interval is c plus 2 pi, because we know sine and cosine have the time period t is 2 pi. It repeats after every 2 pi. So our interval difference is always 2 pi. So if we can want to find out between c and ray, then we can find out the a0 with the formula 1 upon pi c to c plus 2 pi fx dx. We can integrate it and apply the limit. Second constant an is given by 1 upon pi c to c plus 2 pi fx, there is cos nx dx. bn is similarly 1 upon pi c to c plus 2 pi fx sin nx dx. So these are the three Fourier constant derived with the help of Euler formulas. a0 is equal to 1 upon pi c to c plus 2 pi fx dx, fx cos nx dx, fx sin nx dx. n is going from 1, 2, 3, 4. So n is 1, 2, 3, 4 up to. So when we substitute n equal to 1, we can get the first term a1. When we substitute n equal to 2, a2, a3, b1, b2, b3, b4 and so on. So we can expand that function in sine and cosine series. So now we go for some examples how to find out the function, how to convert the function into Fourier series form. So first we go for the one example. I explain two examples. Basically this when we expand any function into Fourier, you concentrate on integration part of this. When you integrate a0 is okay because just you integrate fx. When you integrate this function with cos or with sine and x, you have to and then apply the limit. So when if this integration and limits are okay, then you will get definitely the correct answer. So you concentrate on these integration. So first is find the Fourier series to represent so that 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 4 square plus and so on is equal to pi square by 12. Means this is our Fourier series. We have to find out, we have to expand this function in Fourier series form, and our limit is minus pi to plus pi. So step 1, first you have to write down the formula for the Fourier series. So what is our Fourier series? Fourier series fx is x minus x square is equal to a0 by 2 plus summation n going from 1 to infinity an cos nx plus bn sin nx. Second step, we have to find out a0, an and bn. So first is a0 1 upon pi. Our limit is c to c plus 2 pi. C is minus pi. So minus pi to minus pi plus 2 pi gives plus pi. So our limit going from minus pi to plus pi. Next fx is x minus x square of dx. You integrate it, very simple, and apply the limit upper and lower. You will get the term a0. So a0 is minus 2 pi square by 3. Clear? When we get the a0, then we go for the next an. So what is our an? When we go for the a0, next is our an. An is, I will give you, an is equal to 1 upon pi minus pi to plus pi x minus x square fx cos nx dx. When we integrate this, we have to use always our integration formula. uv dx is equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on. This is our formula for integration by parts. You already read it. So we use this formula. Dash means derivatives. 1, 2, 3, 4 means we have to integrate. So v function always integrate and this u function always differentiable. So it will be vanished. So u function is our that function which is finished after some integration. So u function is this because this x function is finished. V function is this. So v1 is first order integration, then second order, third order, fourth order, like that. So we go for an 1 upon pi. When we integrate u as it is, x minus of x square, then integration of cos nx is sin nx by n minus u dash. Differentiation of this is 1 minus 2x, then integration of this function v2, yani it means we have to integrate 2 times. So one time is this, second time is minus of cos nx upon n square. Clear? Then again u double dash is plus of minus of 2. This one goes 0, minus 2x gives minus of 2. And minus cos nx gives minus of sin nx upon n cube. This is the end of our integration by parts, because next term will goes 0. Now step further, you have to apply the limit very concentrately. When you apply the limit, you know that sin 0, sin pi, sin 2 pi, sin 3 pi, sin n pi, sin for all pi's value is going to be 0. So any term where we have sin, it is 0. So this whole term goes 0, this whole term goes 0, only cos term gives the value. Clear? So we have to apply, no need to apply limits in this, just it goes to 0, we have to apply here. When we apply here, 1 minus first upper limit minus lower limit. So 1 minus 2 pi cos of n pi. Clear? We know cos n pi is equal to, you already, cos n pi is equal to minus 1 to the power n, and cos pi is minus of 1. So you using this fact at the place of cos n pi, you have to write minus 1 to the power n. So when you apply the limit, our an is 1 upon pi, this is 1 minus of n square we have to taking outside, cos n pi also we have to taking outside. So what is left over? 1 minus 2 pi minus 1 minus of 2 pi. Clear? So 1 and minus 1 cancel, minus of 4 pi. So our an gives by minus of 4 pi upon 4 by n square. Cos n pi is minus 1 to the power n. Pi cancel. So what is our an? Is minus 4 upon n square minus 1 to the power n. So now you understand how to find out the an, and similarly same process we have to go for the bn. Next step, we have to find out our bn. So bn is at this place 1 by pi minus pi to plus pi, x minus x square of sin nx dx. Clear? So again you have to apply the formula uv, integration by parts, uv1 minus u dash v2 plus u double dash v3 and so on. U function, what this is u function, what is vanished, this is v function. So when you integrate it, you go for always remove sign terms going to be 0, because sin pi, sin 2n pi, sin n pi goes 0. Cos term gives the solution. So when you integrate, I just skip that part, you have to integrate. Bn gives minus 2 minus 1 to the power n by n. This is our bn. An we already find out is minus 4 minus 1 to the power n upon n square, and a0 we already find what is our a0 is minus 2 pi square by 3. So these all are our 3 Fourier constant which we need for construct a series. So our Fourier series for x minus x square is a0 by 2. So what is our Fourier series? Fourier series is minus 2 pi square by 3 by 2. 2 cancel. So this gives minus pi square by 3 minus 4 taking outside and going from 1 to infinity minus 1 to the power n upon n square cos nx. Again minus 2 summation n going from 1 to infinity minus 1 to the power n upon n sin of nx. This is our general form of Fourier series for this function. Next we have to find out one particular series. For that particular series, we substitute x value of x something. First we have to expand this and then substitute the value of x. When we expanding this, it gives minus pi square by 3 minus of 4. When we substitute n equal to 1, when n equal to 1, minus of 1 cos of x upon 1 square. So minus cos x upon 1 square. Next term gives plus cos 2x upon 2 square minus cos 3x upon 3 square plus and so on. And second term of sine minus 2 summation minus of sine x upon 1 square plus sine of 2x upon 2 square minus and so on. Substitute n equal to 1 because n is going from 1 to infinity. N equal to 1 here first term, n equal to 2 second, n equal to 3 third. Similarly substituting n equal to 1 first term, n equal to 2 second, third and so on. And right hand side is our function x minus x square. Now we need that series 1 by 1 square, 1 by 2 square, 1 by 3 square. For that, if we substitute x equal to 0. So next step for finding that particular series, put x equal to 0. When we put x equal to 0, this goes 0. So our right hand side goes 0 minus pi square by 3 minus of 4. X equal to 0. Cos 0 is 1 because cos 0 cos pi is minus 1. So cos 0 is 1. Cos 20 means cos 0. This all terms going 1. So minus 1 by 1 square plus 1 by 2 square minus 1 by 3 square and so on. Minus 2 and next sin 0 0, sin 2 0, sin 3 0. So this goes 0. Clear? So now what is our term? This goes this side plus of pi square by this 12. Correct? Equal to this minus and minus merge 1 upon 1 square minus 1 upon 2 square 1 upon 3 square minus 1 upon 4 square. So which is our required series for given question. So Fourier series is very easy if you go step by step. If you concentrate when you find out the an and bn, you concentrate on your integration and you apply the limit very properly. I can show you one more example on the Fourier series so you better understand how to solve these Fourier series with the help of Euler's formula. So we go for the second. Same first step, you have to write the formula of Fourier series. X sin x is equal to a0 by 2 plus summation n going from 1 to infinity an cos nx plus bn sin nx. Second, find out a0. I have to write an cos nx plus bn sin nx. Next, find out a0. a0 is 1 upon pi, limit going from 0 to 2 pi. Clear? 0 to 2 pi fx dx. fx is x sin x dx. Same, using integration by parts, you have to integrate 1 by pi. U as it is, integration of sin x is minus of cos x. Then minus differentiation of x is 1. Integration of minus cos x is minus of sin x. 0 to 2 pi. Sin x, this term gives 0, this term gives value. Upper limit minus lower limit. When we apply upper limit 2 pi minus cos 2 pi. And when we apply lower limit 0 goes 0. So only with the upper limit we find out the value. So a0 is equal to 1 upon pi into this is 2 pi, and cos of 2 pi is minus of 1. Clear? Minus of 1. So it gives a0 equal to minus of 2. We have to already find out a0. Keep one side. Second step an, third step bn. So now we go for an. Is 1 upon pi, 0 to 2 pi, fx, x sin x, cos nx dx. When sin and cos multiplied, then we using the formula of sin a plus b, sin a minus b, cos a plus b, cos a. So what? We multiply and divide this. Now 2 of cos nx sin x, we can say 2 cos a sin b. It gives by sin a plus b means sin nx plus x minus sin nx minus of x. Clear? So what is sin a plus b minus sin a minus b gives 2 cos a sin b. What is our? So we replace this term with this term. We break sine and cosine multiplication in individual sign, because multiplication of sine and cosine we can't able to integrate. So with the help of this we break and then we have to integrate it. So substitute here 1 upon 2 pi. This 2 goes here. 0 to 2 pi x sin nx n plus 1x minus sin n minus 1x. Now same we have to integrate by parts. 1 upon 2 pi u as it is. Integration of sin x gives minus cos n plus 1x upon n plus 1 minus this part gives cos n minus 1x upon n minus 1. Clear? Minus derivative of x is 1, integration of this. Integration of cos is again minus sin n plus 1x upon n plus 1 square 1 minus sin n minus 1x upon n minus 1 whole square. And next, with the help of this u double dash, it goes to 0, limit going from 0 to 2 pi. So step 1 complete, we have to integrate very carefully. Next step, we have to apply the limit very carefully with consider all the signs. So now this sign and this sign, all sign at 0 and 2 pi goes 0. So we no need to apply in this, we just concentrate on this part. So we have to apply the limit 1 upon 2 pi. When we apply upper limit 2 pi minus cos n plus 1 2n plus 1 pi upon n plus 1 minus cos 2n minus 1 pi upon n minus 1 upper limit minus lower limit. When we apply lower limit 0, all terms goes to 0. So only this term is remaining. Now we calculate this. What is our minus 1 upon n minus of 1. Clear? Now we have to integrate it. It gives, we have to simplify it. So it gives an equal to 2 upon n square minus 1, where n is not equal to 1. Because if we put here n equal to 1, 1 minus 1 goes 0, indeterminate form. So this is general formula an, but not for a1. N is further greater than 1, 2, 3, 4. This gives A2, A3, A4, A5 up to An, but A1 we can't able to find out. So we have to separately calculate the A1. So this is An. Now we go for A1. A1 is what? 1 upon pi, 0 to 2 pi, x sin x, cos nx. For A1, n is 1, cos 1x dx. Again 2 by 2. So 2 sin x cos x gives sin 2x. So this terms 2 pi x sin 2x dx. Same integrate u into v. 1 upon 2 pi x sin x gives minus cos 2x by 2 minus x is 1, cos 2x gives sin minus of sin 2x by 4, limit is 0 to 2 pi. This gives 0, this gives the value. So with this, A1 is our A1 when we calculate is minus of 1 by 2. A1 is, when we substitute here, 2 pi cancel, cos 2 pi is 1, so A1 is minus 1 by 2. So see, A1 is minus 1 by 2, A2, A3, A4 all we calculate with this An. Similarly, same process for Bn. We go for n gives by this, B1 equal to pi. Now we substitute all these values of A0, A1, A2, A3 with the help of An. We have to find out at least 3 values, A2, A3. With the help of this Bn, we have to find out B1 is this, B2, B3. All values substitute in our Fourier series. A0 by 2 plus summation n going from 1 to infinity means A1 cos x plus A2 cos 2x plus A3 cos 3x up to n plus B1 sin x plus B2 sin 2x plus B3 sin 3x and so on. And you substitute these values. So our function x sin x expand in Fourier series. That's all about the general expansion of the Fourier series. Thank you very much.